Have you ever looked up at the night sky and wondered how stars are born, live, and eventually die? Stars are the lifeblood of the universe. They light up our skies, form the elements in our bodies, and shape the galaxies we see around us. But their journey is not a simple one. It's a process that takes millions, even billions, of years. So let's take a closer look at the incredible life cycle of a star, from its birth to its dramatic death. Stars are born in massive clouds of gas and dust called nebulae. These stellar nurseries are the breeding grounds for new stars. When a disturbance, like a nearby supernova or a shockwave, causes a part of the nebula to collapse under its own gravity, the process of star formation begins. As the gas collapses, it heats up and forms a dense core called a protostar. This core is not yet a full-fledged star. It's still gathering energy and mass. It can take millions of years for the protostar to become hot enough to begin nuclear fusion. Once the temperature in the protostar's core reaches around 10 million degrees Celsius, hydrogen atoms begin to fuse into helium, releasing a tremendous amount of energy. This marks the birth of the star as we know it. Enter the main sequence phase. During this stage, stars are in equilibrium. The outward pressure from the energy produced by nuclear fusion balances the inward pull of gravity, allowing the star to shine brightly for billions of years. Our Sun, for example, is currently in this phase and has been for about 4.6 billion years. It will remain in the main sequence for roughly another 5 billion years. Now, as a star exhausts its hydrogen fuel in the core, it can no longer maintain the same level of fusion. The core contracts under gravity, and the outer layers expand, turning the star into a red giant or supergiant, depending on its mass. The outer layers cool, giving the star its characteristic red color. In this phase, fusion continues, but it shifts to helium and even heavier elements like carbon and oxygen. For larger stars, this process can continue, producing elements like neon, silicon, and iron. The star becomes increasingly unstable as it cycles through different fusion stages. When a massive star has exhausted its nuclear fuel, it can no longer support itself against the pull of gravity. For stars with masses larger than about 8 times that of our Sun, this leads to a catastrophic event: the supernova. A supernova is an explosive death, where the core collapses inward, triggering a massive explosion that can outshine an entire galaxy for a short time. This explosion disperses heavy elements like gold, uranium, and iron into space, enriching the interstellar medium and giving birth to new stars and planets. For smaller stars, like our Sun, they don't explode. Instead, after expanding into a red giant, they shed their outer layers and leave behind a hot, dense core. This core becomes a white dwarf, which will gradually cool and fade over billions of years. However, for the most massive stars, the end is even more dramatic. After a supernova, the remaining core can collapse into either a neutron star or, if it's massive enough, a black hole. A neutron star is an incredibly dense object, made almost entirely of neutrons. It's so dense that a teaspoon of neutron star material would weigh as much as all of humanity combined. Some neutron stars emit beams of radiation, becoming pulsars, which can be detected from millions of light years away. On the other hand, if the core is massive enough, the collapse leads to the formation of a black hole. A black hole's gravitational pull is so strong that not even light can escape it, making it invisible to the naked eye. Black holes are mysterious, powerful objects that warp the fabric of space and time. After a star dies, its remnants are not gone forever. The materials it ejects into space, rich in elements like carbon, oxygen, and iron, are essential for the formation of new stars, planets, and even life. This cosmic recycling process ensures that stars, even in death, contribute to the creation of the next generation of stars. From the dust of a star's death, new stars are born, continuing the cycle of life, death, and rebirth in the universe. So the life of a star is not just a magnificent display of energy and light. It's a cycle of creation and destruction, shaping the universe we live in. And as the stars live, die, and explode, they leave behind the very elements that make up planets and life itself. If you enjoyed learning about the amazing journey of stars, don't forget to subscribe to our channel. By subscribing, you'll stay updated with more exciting insights about the universe, space, and everything in between. Together, let's explore the wonders of the cosmos. Until next time, keep looking up at the stars.